Hello everyone, my name is Jun. In this presentation, we will discuss some of the initial research findings on the concept of mass-tailorisation and how it may be able to aid the decision-making process of the designer. What we are seeing here is the production line for the Ford Model T, considered as the first affordable car. By repeating the same output over and over again, efficiency is achieved within the system, hence unit costs are lowered. This later becomes known as mass production, perfectly explained by Henry Ford's statement, "You can have it in any color as long as it is black." As technology developed over time, the idea of mass customization was found. Unlike mass production, mass customization tells us, you can have it in any color. Mass customization allows for tremendous variations of the output while maintaining the efficiency that is achieved in a mass production system. However, the very strength of mass customization can also become its own weakness. While the phrase, "you can have it in any color," gives us the freedom to choose, it poses the threat of creating the paradox of choice, where making a single decision becomes too difficult because of the numerous options. Running parallel to the idea of mass customization, the idea of the digital continuum started to gain momentum. The act of designing, fabricating, and assembling through the digital environments is enabling us to create in unprecedented volumes and complexities. Consequently, the possibilities enabled by the digital continuum may pose complex implications in the decision-making process of the designer. With mass-tailorisation, we want to address this problem. Like mass customization, mass-tailorisation tells us you can have it in any color, but it also lets us know that if you need a family car, a blue, green, or a red car might be the best, so which one would you like? By applying an additional layer of specific design context, such as a family car, mass-tailorisation aims to reduce the likelihood of the paradox of choice. However, like mass customization, one can revert back to the tremendous variations if wanted. As such, the ultimate aim is to allow the user to have more control over their own decisions in a world of complexities, while ensuring that those decisions are beneficial to the design context in question. Unlike selecting a color for a car, due to the complexity of the unlimited possibilities in architecture, the research of the potential for mass-tailorisation within the digital continuum of architecture began at a smaller, definable scale. In order to test these ideas, the Burr puzzle was chosen as the first case study. What we are seeing here is called the 6-piece Burr puzzle. In our study, this puzzle was used to study the implications and the relationship between the digital continuum, mass customization, and mass-tailorisation. The Burr puzzle is made up of 6 pieces. Each piece can be made up of up to 24 cubes, of which 12, 6 at each end of the piece forming an L shape, are constants on every single piece. The remaining 12 central cubes form the variables for each piece. One may have from none to all 12 and any permutation in between. Applying this logic, there are 4,095 possible pieces that can be generated. However, removing invalid pieces, such as those that are made up of 2 separate parts, reduces the possible pieces to 2,225. Now, we are ready to establish a digital continuum. To digitally design the Burr puzzle, an algorithm will need to select 6 pieces from the pool in a specific sequence to determine whether the chosen pieces in the chosen sequence can create the Burr. Once an algorithm has established an iteration of the Burr puzzle, the digital information of the designed Burr puzzle can be transferred for digital fabrication. In the olden days, there was a group of 59 pieces labeled as the 59 notchable pieces. These were considered as the only pieces that were easy to fabricate using hand tools. Therefore, most Burr puzzles were only generated using the pieces that were part of this group. However, with the advent of digital fabrication technologies such as CNC machines and industrial robotic arms, the 59 notchable pieces is no longer the case. Any one piece is no more difficult to digitally fabricate than the other. Through the digital fabrication technologies, the 59 notchable pieces become 2,225 notchable pieces. This, in turn, provides greater number of iterations possible for the design of Burr puzzles. The same digital information that was generated by the algorithm and sent to fabrication can also be utilized for digital assembly using augmented reality headsets. The assembly sequence of the puzzle can be broken down to a step-by-step process and visualized through AR. This allows any puzzle to be assembled in under 10 minutes. Without the aid of digital assembly, each puzzle can take hours or days to assemble. The digital continuum is now complete. However, the establishment of the digital continuum does not necessarily result in a mass-tailorization system. In fact, it has the potential to create the paradox of choice. It has been estimated that there are approximately 71.3 billion possible iterations of the Burr puzzle using the pool of pieces. Theoretically, the establishment of the digital continuum has allowed access to all 71.3 billion of the possible iterations. Therefore, as things stand, the digital continuum has brought the paradox of choice upon the Burr puzzle. This is because, should the digital continuum be able to create all of the iterations, there is no clear and logical method for the user to select one output over another. This is because each of the puzzle pieces did not have specific design context beyond its role as a Burr puzzle piece. Due to the context-less nature of the pieces, the designed puzzles become context-less beyond its Burr design. Thus, no puzzle can become more valuable than the other, as all designed puzzles are now only Burr puzzles. This leaves the selection of a single Burr puzzle to a near-random selection based on inefficient, ineffective reasoning. The user has experienced the paradox of choice and has lost control of the decision-making process. If mass-tailorization is a filtering of numerous outputs through a specific design context, it could be said that the grouping of the 59 notchable pieces was an unintended beginnings of mass-tailorization for the Burr puzzle. This is because calling the pool of pieces due to limitations in fabrication significantly reduced the number of possible variations of the puzzle. Perhaps it could be speculated that this is an early version of mass-tailorization where the filtering occurs in its most primitive form, as a binary condition to the fabrication limitations of the time. The specific contextual criteria being a Burr puzzle that can be made from the 59 notchable pieces because those pieces are the only pieces that can be fabricated. Interestingly, the traditional Burr puzzle has another group of pieces that has the characteristics of mass-tailorization. Traditionally, it was customary for a Burr puzzle to be only solid, having no internal voids. Therefore, if only solid Burr puzzles are considered, there are only 25 notchable pieces out of the 59 notchable pieces that can satisfy this specific context. These are known as the 25 notchable pieces. Using these 25 notchable pieces, there are 314 solid Burr puzzle variations that can be formed. In this example, the purposeful decision for a specific aesthetic has called the number of variations for the Burr puzzle, which in turn called the number of pieces in the pool. A critical difference between this example and the 59 notchable pieces is that the 25 notchable pieces begin to mass-tailorize due to design intentions rather than design limitations. Furthermore, and perhaps more importantly, a critically holistic difference between the two groups of pieces is that the 25 notchable pieces mass-tailorize the Burr puzzle through the design output, whereas the 59 notchable pieces mass-tailorize the Burr puzzle through the design inputs. In this sense, mass-tailorisation could be achieved at both ends of the creating process. Like the 59 notchable pieces, a mass-tailorized Spur puzzle system could work at the design input stage by grouping a select few pieces that respond to specific design context, such as the pieces that are easiest to fabricate or the pieces that are most aesthetically pleasing. Alternatively, it could also work at the design output end of the process that respond to the specific design context in its entirety, such as a Spur puzzle that is most aesthetically pleasing. Future research would begin to test these design input and output stage design contexts to determine how effective these may be able to aid in the decision making of the designer. I thank you for your attention.